आज हम लोगों का टॉपिक है वन डायमेंशन मोशन, मोशन इन वन डायमेंशन. First question, for the velocity time graph shown in this figure in an interval from t is equal to 0 to t is equal to 6. Here is time, here is velocity. This is t is equal to 0 to 4, 6. Okay. Match the following. We have to calculate so many quantities and match with the answer. So we have to find 4 answers in this. Okay. So first is change in velocity. Change in velocity in 6 seconds. 6 seconds the graph is complete. At time 0 the velocity is 10. At time 6 velocity is 0. Do not get carried away with this line. No. Sirf you have to see only 2 locations. When time is equal to 0, when time is equal to 6. When time is equal to 0, velocity is 10. When time is equal to 6, velocity is 0. So, how much is the change? Change we will calculate for question number A. Final velocity is final minus initial. Final velocity is 0. Initial velocity is 10. The answer is minus 10, and here we get minus 10. That is R. So A will match with R. Now the second, average acceleration. Average acceleration. Whenever we find the word average, then we solve it in this way. We know that acceleration is velocity upon time. Change in velocity, change in time, that gives the average acceleration. Okay, there is a difference in average acceleration and instantaneous acceleration. Instantaneous is slope at one point. Average is total change divided by total time. So, for average acceleration, B, total change in velocity, change in velocity, total and total time taken. Here change in velocity is minus 10. Total time taken is 6 seconds. So this is minus 5 upon 3, and this minus 5 upon 3 is P. So we get this answer P. So B is matched with P. B matched with P. Okay. Now third, total displacement. Displacement is again in VT graph. This is V, this is T. In VT graph, the area gives the displacement. And here we will calculate area, because we are calculating displacement. It will be affected by the sign also. And we have to see the sign of velocity, that will give velocity into time, that will give sign to the displacement. Okay. Now we have to calculate total displacement. We divide it into 3 parts, 0 to 2, 2 to 4, 4 to 6. And here velocity is plus 10, time is 2. So the displacement for the first is plus 10 multiplied by plus 2. For the second part, 2 to 4, the velocity is minus 10 multiplied by 2 seconds. This area will be given by minus 10 into plus 2. This is the second area. And third area, again remember, we have divided it into 3 parts to calculate area. This is first figure to get the area, this is second figure to get the area, this is third figure to get the area. So the area for the third figure, minus 10 multiplied by plus 6. minus 10 multiplied by plus 6. So this is, sorry, not 6. From this place to this place, it is only plus 2. So this is to be multiplied by plus 2. Now this is 10 to the 20 minus 20 minus 20. So this comes to be minus 20, and here we find it is Q. Q. Okay, so C match with Q. A match with R, B match with C, Q. So fourth is obvious, D has to match with S. Will it? Okay, let us ensure at t is equal to 3 seconds, t is equal to 3 seconds, here is 3 seconds. 3 seconds we get the slope of this line. Slope of this line. Slope, how do we get? By tangent. This is perpendicular, this is base, the perpendicular is minus 10. Perpendicular minus 10 and the base is 2. 2. What we are getting it? Tangent. Why we are getting the tangent? Slope. Why we are getting the slope? Because in VT graph, acceleration. Which acceleration? Instantaneous acceleration. Instantaneous acceleration is equal to slope. Slope is equal to tan theta. Tan theta is equal to perpendicular upon base. Here perpendicular is minus 10. Base is plus 2. So minus 10 upon plus 2 is equal to minus 5. And that is our last answer, S. So D match with S. So this is how we will solve this. Here is another good question. Velocity of a particle is in negative direction. That means if this is plus direction, this is minus direction, the particle is going in this direction. The particle is going in this direction with constant acceleration in positive direction. So this is the direction of velocity, but this is the direction of acceleration. It's a very easy example. एक पेंडुलम, ये उसकी मिड पोजीशन है और मिड पोजीशन से जब ये इधर जाएगा, ऐसे जब ये इधर जाएगा तो वेलोसिटी की डायरेक्शन इस तरफ है, लेकिन एक्सीलरेशन इधर है, यानी रिटार्डेशन है, और यहां पहुंचते पहुंचते जीरो हो जाएगा. सो दिस इज व्हाट डज इट मीन? वेलोसिटी इज इन नेगेटिव डायरेक्शन and acceleration is in positive direction. Okay, now we have to match the following: velocity time graph. What is the slope of velocity time graph? It speaks about the slope, all of this. How will be the velocity time graph of this particle? So let's make the velocity time graph. This is velocity, this is time, and the velocity is negative. Velocity is negative. Acceleration is positive, so velocity goes on decreasing. The velocity is in this direction, acceleration in this direction. So what will happen to the magnitude of velocity? The magnitude of velocity will decrease. This will reduce. So it is 10, 8, 6, 0. 10, this time 8, this time 6, this time 0. So this is the graph. This is the graph for velocity time. Okay, if this is velocity time graph, we have to reply the slope. This slope is negative or positive. What is a negative and positive slope? Any line which is going down has got negative slope, and any line which is going up has got positive slope. This is going up. Please don't see here, don't see here, don't see here. Only see this with respect to horizontal. The answer is it is going up. So if it is going up, then it is positive slope. Positive slope is option Q. So for A we have option Q. Then slope is increasing, decreasing or constant. What does it mean? It means the slope at this time during this time is this. The slope during this time is this. The slope during this time is this. Is there any difference in this slope? ये तीनों के स्लोप में कोई डिफरेंस है या तीनों एक ही डायरेक्शन में है? तो आंसर है तीनों एक ही डायरेक्शन में है। स्लोप चेंज कब होता है? जब ये वाली लाइन आगे जाके ऐसी हो जाए, द स्लोप हैज इंक्रीज। ये लाइन ऐसे गई, आगे जाके ऐसे हो गई, द स्लोप हैज डिक्रीज। बट हियर द सेम डायरेक्शन, सेम डायरेक्शन, सेम डायरेक्शन। So what we will say, how is the slope, which nature? The answer is slope is constant. So that is u. So A is matched with Q and A is matched with U. Now come to the second one. Acceleration time graph. Acceleration time graph for this particle. Now we will change the graph. And we have this acceleration time graph. This is acceleration and this is time. Here acceleration is positive. Initial acceleration is positive. Then acceleration is positive. Is there any change in acceleration? See the word. Constant acceleration, no change in acceleration. At 0 second, acceleration is this much. So after 1 second, acceleration is this much, same. After 1 second, again acceleration is same. After 1 second, again acceleration is same. So what we get here is a straight line. This is acceleration with reference to time. Okay, now if this is acceleration to the time, then we have to find the match. First, how is the slope? Negative, positive or zero? Positive slope going up, negative slope going down this way, and zero slope going straight. So you can match it, it is zero slope. So B has first match with zero slope, that is R. Okay, then slope is increasing, decreasing or constant. No change in the slope. It remains same. We can say it is constant. So this will also be U. Okay, now see displacement time graph. Displacement time graph, we will go for displacement time graph. Here the velocity is decreasing because of acceleration. The velocity is decreasing. You have seen the pendulum. The velocity is in this direction. Here velocity is large. Here velocity has become zero. Now what is happening to the displacement? Answer, displacement is here, very well here. Positive or negative? Negative. Is the displacement same for every second of time? Initially displacement, then displacement, then displacement. So logically we can think here the velocity was high, so the displacement is large. Then velocity has become zero, the displacement has become less. Again the velocity has become zero, so the displacement has become further less. So displacement is increasing. No doubt displacement is increasing, but here initial rate of displacement was high. For the second it was less, for the third it was less, for the fourth it was still less. What type of graph it is? So the answer is, to see the graph, this is a retarding motion, and for retarding motion we have the formula for x with reference to time, and that is your second formula. S is equal to ut plus half at square. See, here t has power 2, s has power 1. So what will be the shape of the graph? The answer is, shape of the graph will be a parabola. If it is 1 and 1, like v is equal to u plus at. t is 1, v is 1, and the slope is constant, it is a straight line. But if it is 1 and this is 2, then it is parabola. For every 1 second, the change of displacement will be different. For the second, it will be different. So it starts from ut. This x has the value ut because it is on negative side. We will take it here. Now it goes on decreasing. It goes on decreasing, and this is 1, this is 2. This makes a parabola, and finally it reaches 0. So this will be initially, this will be fast, then it will be slow. So this is our graph. This is part of the parabola, and after some time the velocity, the displacement will become 0. No, is there anything wrong? Displacement has become here. No, I have done a mistake. Let's correct it. Here we take t is equal to 0. And here t is equal to t. So when t is equal to 0, displacement is 0. When t is equal to 0, displacement is 0. Now initially the displacement goes to the negative side very fast. It goes very fast. And then it becomes slow and reaches the maximum value. This is x maximum. And we know x maximum is amplitude. So this is our answer for this. But how does it make the difference? See, displacement time graph. How is the slope? The answer is slope is negative. So if the slope is negative, we will write C match with P. The second thing, the slope is increasing, decreasing or constant. Here slope is more, then slope become less, it become less, it become less. And no there. So what is happening to the slope? The slope is decreasing. Large slope, smaller slope, no slope. So the slope is decreasing. The slope is decreasing, that will give the option T. Again, once again, how we find, you see, there are 4 type of graphs possible with power 1 and 2. Like, we can have a graph like this, we can have a graph like this, and we can have a graph like this, we can have a graph like this. How do we choose? The answer is, first thing, this. When the time is equal to 0, when the time is equal to 0, how much is the displacement? 0. So it gives x height is equal to 0 when the time x-axis is equal to 0. This is the point. X is equal to 0, t is equal to 0. Here t is there, time t has passed, and what about the x? X has become maximum. At the time t, x has become maximum. This. So this is not there because this is going to be x0. Not possible, not possible. So what are the options we have? We have only these 2 options. Where initially x is 0, finally x is so large on the negative side. Okay, how do we choose out of these 2? Initially the x falls very rapidly. शुरू में x तेजी से कम होता है. इसमें हम क्या देख रहे हैं? शुरू में धीरे धीरे कम होता है, बाद में तेजी से कम होता है. इसमें शुरू में फास्ट तेजी से कम होता है और बाद में स्लो कम होता है. So here which thing is matches? This one matches. शुरू में तेजी से बढ़ेगा और बाद में स्लो. शुरू में तेजी से नेगेटिव होगा, बाद में स्लो. So this is our right option. Yes. And in the words, what does it mean? It means the slope is negative, number 1, and the second thing is the slope is decreasing. How decreasing? First it was more, then it was less, then it was less. So the slope is decreasing. So here it's a very wonderful question where they have asked for at least 5-6 questions in one question. So this is how we can make it. So these are our answers for this. Okay, you can revise it again. Now we go to the next question. Again, same style of question. We have to give 4 answers in one question. The equation is 1, s is equal to 10 plus 22 minus 3t square. Match the following. Distance travelled in 3 seconds. Distance travelled in 3 seconds. What this equation speaks about? This equation speaks about distance or the displacement. Okay. In the ST equation, this is a displacement equation, and 3 seconds. If we put this value equal to 3, what do we get? So the answer is for 3 seconds, we are solving A. For 3 seconds, S is equal to 10 plus 20 into 3 minus 5 into 3 square, that is 9. 9 5s are 45. 10 plus 60 minus 3 3s are 9. 9 5s are 45. So this is 70 minus 45. 70 minus 45 is equal to 25. Now what is this 25? Is it a displacement or is it distance? The answer is it is distance. Okay. If no, the answer is this equation is ST, that is displacement equation. If this is a displacement equation, then what we have calculated is displacement. So this is displacement, and this will give our answer for if there is a displacement, but there is no question of displacement. They only want distance. Okay. So this should be 25. Now let us check it again in the graph. This is xt graph. When the time is equal to 0, what is the position? Time is equal to 0, 0, and the position is 10. Okay, I will make it this way. It is a straight line, straight path. A particle starts from here. T is equal to 0. When the time is 0, the location is, this is axis, the location is 10. 0, 0, s is equal to 10. S is equal to 10 when time is equal to 0. So this is to be written like this. Now after 1 second. After 1 second, what will happen? This will be 1, 10 plus 20, 30. 30 minus 5 is 25. So this will be at 25. 10 and this is 20, 25. 25. How much is the time? The time is equal to 2 seconds. Now, after 3 seconds, we place here 3 and this becomes again 25. Oh, yes. With 2, it is 25. See again, S is equal to 10 plus 2 into 20, 40 minus 2 2s are 4 5s are 20. I am sorry. 2 2s are 4 5s are 20. 2 into 20, 40. This is time is equal to 1 second. I am sorry. When we place 1 here, then it is 10 plus 20, 30. 30 minus 5, 25. 25. Okay. When we place t is equal to 2, t is equal to 2, s is equal to 10 plus 40 minus 2 to the 4, 5 is 20, and this becomes 50 minus 20, that is 30. Okay. अगर ये 30 हो गया तो टाइम क्या है? 2 सेकेंड. Here time 2 seconds and the distance is 30. This is here and it is 30. 30. Now again, S is equal to this much. This is 10 to 25, then to 30. That shows the speed is decreasing. So there are questions related to velocity. There are questions related to acceleration. So we should also convert this equation into equation of velocity and equation of acceleration. If this is our equation of displacement, then what will be equation of the velocity? Okay, if you place t is equal to 3, s is equal to 25. So this is t is equal to 3. Now what do we understand? The object has gone here, then it has come here. 1 second, 2 second, 3 second. It is an oscillation. Oscillation sort of thing. Here velocity was more. It has come from somewhere here. We started calculating from here. यहाँ से हमने calculation शुरू की है, इसलिए यहाँ पर हमने क्या लिया? T is equal to 0. If T is equal to 0, T is equal to 1, T is equal to 2, and again back T is equal to 3. Okay. Now if it has gone like this, then okay, first we'll find the formula for velocity. If we have S is equal to 10 plus 20t minus 5t square, then velocity is equal to 0 plus 20 minus 5 to the 10t. This is our formula for velocity, and what will be formula for acceleration? Again differentiate. V is equal to ds by dt, and acceleration is equal to dv by dt. So acceleration is equal to, this has become 0 and this is minus 10. No t. No t, what does that say? That says that acceleration is constant. With the time it does not change. So it will not change with respect to time. So this is acceleration, this is velocity, and this is this. Okay. When the velocity will become 0? This. At the extreme velocity will become 0. But what is the time? Okay, let's find out time. Velocity is 0. V is equal to 0 when t is equal to, V is equal to 0, 0. So this will be minus 20 and t is equal to 2 seconds. That means when time is equal to 2 seconds, velocity has become 0. Now position is very clear to us. We make the graph, it starts. When the time is 0, the displacement is already 10. Here we have started our stopwatch, and when the time is 1 second, this displacement is 20. When the time is equal to 2 seconds, the displacement is 30. What is happening to velocity? The velocity becomes 0 when time is equal to 2. Here velocity is 0, here velocity is full, whatever it is. T is equal to 0, T is equal to 0. So velocity is how much? 20. Velocity is equal to 20. At 1 second, put it 1. So velocity is equal to 10. Now you see, time is equal to 1, time is equal to 2, time is equal to 3. How is S equal to? 10 here, 25 here, 30 here. Velocity is 20 here, 10 here, 0 here. And acceleration is equal to, minus 10 here, minus 10 here, minus 10 here. At all the time, The acceleration is in this direction because it is minus, minus, minus. And it's a constant here, here, here and come back here. Again, it is minus 10, it's a constant. Okay. Now, this is the total situation and now we can find out our answers very well. Okay. The distance traveled in 3 seconds. From here, from 10, it goes to 25. 10 to 25, then it goes to 30 and then it comes back to this position. How much is the distance traveled? The distance traveled is 15, 5 and it again goes back 5. 15 plus 5 plus 5. 5, 5, 10 and 15, that is 25. Any answer? Yes. This is 25. So A match with R. R. Now B. Displacement in 1 second. Displacement in 1 second. At the 0 point, displacement in 1 second, we place t is equal to 1. If we make t is equal to 1 here, then it comes to be 1, 1 and this will be 10 plus 30, 30 minus 5, 25. Here is the particle. Okay, now when time was 0, it was here. When time is equal to 1, it is here. How much is the displacement? The answer is displacement is 15. Okay. The displacement from this place to this place is 15. Do we have any answer 15? Yes, it is 15. So B match with Q. Okay. What is this ST equation? ST equation is what? So the answer is ST equation is position equation. Position. The position at time is equal to 0 when we start our wristwatch, when we start our clock. So next thing, initial acceleration. Acceleration we have found it is always minus 10. Even time is 0, time is 1, time is 2, does not matter because there is no t here. So acceleration is always minus 10. So whether it is initial, final or in between, it is always minus 10. So C match with minus 10, that is S. And then velocity at 4 seconds. Velocity at 4 seconds. See the formula for velocity and put t is equal to 4. So this will be 4 minus 40 plus 10 minus 40 is equal to minus 20. Do we have minus 20? Yes. Velocity at 4 seconds minus 20 p. So D matches with P. Here D matches with P. Okay, so we got all the answers. Now, in this explanation, when we are doing it, we have taken quite a lot of time. This much time we are not supposed to waste in an examination. So, if I am asked this question in the examination and I am well prepared, then how do I solve it? How do I think it fast? देखिए एक्चुअल टाइम इसको देखने के बाद एक्चुअल टाइम कितना लगना चाहिए थोड़ा उसको देखिए. स्टार्ट नाउ. इन ST equation, that is position equation, match the following: distance, displacement, acceleration, velocity. I see velocity is there, acceleration is there, displacement is there. So I differentiate this equation so that I get the equations of velocity and acceleration. I start. S is equal to 10 plus 20t minus 5t square. Velocity is equal to 20 minus 5 2s are 10. 10 t, and then acceleration is equal to, again differentiate this, 0 minus 10. So I got the equations of position, velocity as well as acceleration done. Now I go for the answers. Distance traveled and displacement. That means I will have to draw the graph for calculating the distance. I start. T is equal to 0. Make the table. T is equal to 0, 1, 2, 3, 4, like that. When t is equal to 0, s is equal to 10. When t is equal to 1, s is equal to 10 plus 20 minus 5, that is plus 25. When t is equal to 2, then it is 10 plus 40 minus 2 2s are 4, 5s are 20, minus 20. 10 plus 40, 50 minus 20. 50 minus 20 is 30 after 2 seconds. And when the time is equal to 3 seconds, 3, this will be again 3 20s are 60. 10 plus 60, 70, and this will be 45. 70 minus 45 is equal to 25. Again, this is plus. This gives the position. So according to this, again, I take the velocity, acceleration. Velocity, when time is equal to 0, velocity is 20. When time is equal to 1, velocity is 10. When time is equal to 2, velocity is 0. When time is equal to 3, velocity is minus 30, minus 10. This is velocity. Okay, acceleration, no t is here, so it is always minus 10, minus 10, minus 10, minus 10, all the time. Now after knowing this, I would like to draw the actual path. Why actual path? Because there is a question for distance, and the distance is actual path travelled by the particle. So I have to draw the actual path. Okay, I started when t is equal to 0. 1, 2, 3. Only 3 seconds. So here t is equal to 1. T is equal to 0. The position is plus 10. It starts from somewhere here. Here the position is plus 10. Okay. T is equal to 1 second. T is equal to 1 second. This is plus 25. Plus 25. T is equal to 2 seconds. T is equal to 2 seconds. And this is 30 only. 25, 30. T is equal to 2 seconds. It goes here. But I find when t is equal to 2 seconds, velocity has become 0. It will not move any further. What will happen? 3. Again it is at 25. 3. Again it is back to 25 like this. And velocity is minus 10. That means it is going in this direction. Here velocity is minus 10 and here velocity is 0 and here velocity is plus 10. T1 velocity was, while it was going here, the velocity was plus 10. When it is coming back, velocity has become minus 10 and at 3 seconds it is at this point. At 3 seconds this is at this point, so this is also time is equal to 3. So time is equal to 0, time is equal to 1, time is equal to 2, again time is equal to 3 for this. Okay, acceleration everywhere minus 10 and now I got the answers. Distance travelled in 3 seconds, I calculated, I have to start from here. So I don't consider this part. From here distance travelled 15 plus 5 20, 20 and 5 25. So my first answer is 25. So I write A match to R. Then for second, displacement in 1 second. Here is the initial position, t is equal to 0. Here is t1. So the displacement is how much? Final position minus initial position. Final position is 25, initial position is 10. So 25 minus 10 gives plus 25 minus 10. So this is equal to plus 15. So I get it plus 15. So displacement is plus 15. After that, initial acceleration. Acceleration is always 10. So acceleration is always 10. Okay. Then acceleration is minus 10. Acceleration is minus 10. And then velocity at 4 seconds. Then velocity at 4 seconds. Velocity at 4 seconds. So I will put t is equal to 4 here. When t is equal to 4, then it becomes minus 40. 20 minus 40 is equal to minus 20. So that answer is minus 20 unit velocity at 4 seconds. So this is the actual time it is required. So it has to be done. For understanding it's alright. You give so much time. But while solving it in the examination, it must be. Next question. Match the following. There is no question as such. Some statements are given. First is constant positive acceleration. Here, this is a position of the body and it is having a constant positive acceleration. If this side is plus, this is minus, then there is a acceleration on this side and the magnitude of acceleration is constant. That means it goes on increasing velocity with a same rate. Acceleration. Okay. Then what will happen to speed? What will happen to speed? Remember, there are two options. We do not know to which direction the body is going. It may have velocity in this direction. It may have velocity in this direction. But what they have given is positive acceleration. They spoke about acceleration only, not about velocity. तो अगर इसमें acceleration positive है, तो दोनों पे इसका effect अलग अलग होगा. If velocity is positive, this acceleration will increase the speed. If it is negative, this acceleration on this side, velocity on this side, so this will decrease. So what will happen to speed? The speed may increase, the speed may decrease, because it is not given, though there are two options. And here we find speed may increase, speed may decrease. There is speed must increase, speed must decrease. What does it mean, must? Must means there is no other go. It has to increase or it has to decrease. But we say no. It may increase, बढ़ भी सकती है, कम भी हो सकती है. It is not necessary that it must increase. It may decrease also. If velocity was on this side and acceleration this, so it may decrease also. So what will be our options? P and Q both are correct with reference to A. So for A, we write the answers P and Q. P, Q. Both are correct. Right? Then we consider what should be the answer for B. This is constant negative acceleration. Constant negative acceleration. Now, acceleration is negative. If acceleration is negative and it is in this direction, again, this speed will increase, this speed will decrease. So speed may increase, speed may decrease. Again, we get the same thing, P and Q. If there had been one definite answer, we would use must. If there is no change in velocity or the speed will become 0, then we will use this. But it may increase, it may decrease, so it is again P and Q. Now for C. Constant displacement. Constant displacement. When the displacement is constant, what does it mean? That means displacement is having the same value. Then what is happening to speed? Displacement. From here, a particle is at a displacement of 10. From here, the particle is at a displacement of 10. After 1 second, it is again at a displacement of 10. After 2 seconds, it is again at a displacement of 10. After 3 seconds, it is again at a displacement of 10. What we are telling? Constant displacement. Displacement is not changing. What is happening to this body? You will say it is not moving. So if it is not moving, what is its speed? The answer is speed is 0. Speed is 0. So this is our right option for C. That means if the displacement is not changing, that means the body is not moving. Okay. Then D. Constant slope of AT graph. AT graph. AT. And the slope is constant. What is given by slope in the AT graph? Slope in any graph is given by tangent, and tangent is given by perpendicular upon base, and perpendicular here is A and base here is T. A upon T. What does it give? Constant slope of AT graph. With time, acceleration is increasing, with time, acceleration is decreasing. If it's happening that acceleration is increasing or acceleration is decreasing, again, same thing. If acceleration is increasing, the speed will increase at double the rate. If it is decreasing, the speed will decrease at double the rate. So, speed may increase, speed may decrease. So, again, it is P and Q. Okay. You may say it's a very funny question. Okay. It may be there, but it says whether you can think it correctly. So, these are our answers. These are our arguments. You can go. See the question. A balloon rises up with constant net acceleration of 10 meters per second square. After 2 seconds, a particle drops from the balloon. Let us think about the diagram. A balloon rises up with constant net acceleration. From here, a balloon is rising up, and it has got some acceleration, and that acceleration is 10 meters per second square. Okay, it is going up. It is going up. From here it starts. After 2 seconds, a particle drops from the balloon. Now, when a particle is dropped from the balloon, what should be its velocity? If we drop it here, here, or here, what does it? The difference. What is the difference? The answer is whenever we drop a particle. Whenever we drop a particle, its velocity is same as velocity of balloon. जब भी हम particle को छोड़ेंगे, उसकी initial velocity कौन सी होगी? जो इस balloon की velocity है, that is due to inertia of velocity. तो यहाँ पर अगर हम इस particle को यहाँ पर छोड़ते हैं, तो ये particle initially कहाँ जाएगा? Answer है balloon was going up, so it will also start going up. Yes, but G will take it over, तो ये ऐसे ऊपर जाएगा, जाकर इसकी वेलोसिटी कहीं पर 0 हो जाएगी. यहाँ पर उसकी कुछ वेलोसिटी है, जो बैलून की वेलोसिटी है यहाँ पर v. ये v इसका इनिशियल वेलोसिटी है. Then it will rise up, velocity will go on decreasing because now the acceleration has become how much? G. So its velocity will become 0. Then due to G, its velocity will be developing in the bottom direction towards ground direction, and the velocity will go on increasing. And finally it will reach here. This is the situation what is given to us. Now we have to get answers for the 4 questions. Number 1. Height of the particle from the ground. When? After 2 seconds. After 2 seconds of what? After 2 seconds, the particle drops from the balloon. after further 2 seconds, we have to give this answer. So, what are this 2 seconds and what is that 2 seconds? This 2 seconds, the balloon is rising up. This 2 seconds. In this 2 seconds, it will reach here, then we will leave it, drop the particle, and the particle will move like this. We have to give the answers for which situation for the particle when it is coming down after further 2 seconds. Okay. Now let us start. We have to find height of the particle. 2 seconds here, then 2 seconds here. It may be somewhere here, anywhere. We don't know. That is, we are supposed to find out in question number 1. Height from particle from the ground after further 2 seconds. After further 2 seconds. Okay. So we will start with, we want to go for this equation where u is equal to this velocity, and after 2 seconds, how much is the distance? How much is this distance? So there are so many questions involved in this. Okay. We want to find, how do we think? We have to find out height. Height is what? S. For S, related to what? T or V? Answer is related to T because further 2 seconds. So S has an equation related to T, that is S is equal to ut plus half at square. इसके सारे डाटास हमको चाहिए. देखिए कौन कौन से डाटास चाहिए. U इनिशियल वेलोसिटी, ये पार्टिकल की इनिशियल वेलोसिटी u. We must know this. At present we don't know. We will calculate it. T 2 seconds, that is given after further 2 seconds. So this is known to us. ये हमको निकालना है. A acceleration, when the moment it leaves the balloon, it has acceleration equal to g. Till it was in the balloon, it was having acceleration it was having certain acceleration, that was 10 meter per second square upward. Okay. Now this A is equal to g, so it is known to us 10. This T is again 2 seconds known to us. If this is known quantity, this is known quantity, we have to find out only u, initial velocity of this. Now how do we get the initial velocity of this? Initial velocity of this, okay, it starts from here. A balloon rise up, start from here. We take this equation for the balloon. For balloon, u is equal to 0, acceleration upward is equal to 10, time is equal to 2 seconds. What will be the v? Vu 80, so v is equal to u plus 80, 10 to the 20. So v is equal to 20. When the balloon reaches a speed of 20, then we drop the particle. So what is the speed of the particle? Answer, speed of the particle is same as speed of the balloon, that is 20. So this u we get as 20. This u is equal to 20. Now forget the balloon. Okay, before forgetting the balloon, let us calculate what is the position of this, because we have to calculate height from the ground. So we must remember at starting position what was the height. So S is equal to, again we take help of this. S is equal to ut plus half a t square 2 square. This is equal to 2 into 2. So this 2 is cancelled, 10 to the 20. So S is equal to 20. Now from here the particle start, it has got velocity is equal to 20, this height is already 20 and it starts from there. Now when it starts from there, then how much height it covers in next 2 seconds? In next 2 seconds, how much height it covers, because we have to get the answer at further 2 seconds. S is equal to 20 into t. Mind the sign here, it's very important. We are taking this sign plus and this direction minus. Initial velocity is upward, so it is plus 20 into t, and t is 2. Then half, acceleration is g, and this is downward. Because this is downward, this will be minus 10 ut plus half a t square, that is 2 square 4. This. So this is 20 to the 40, this is 20, so minus 20. 20. Okay, the S is 20. Okay, if S is 20 plus or minus, answer it is plus. It has come to be plus. Its initial velocity was 20. S is equal to ut plus half a into t square. So S is equal to 20. Okay. Okay. So this is plus 20. It was already at a height of 20. In 2 seconds, it has again gone to the distance 20. So the total distance from ground is 20 plus 20. That is equal to 40. Is there any answer? 40. Height of particle from the ground, 40 units. So A will match, A matches R. Okay, let's go for B. Speed of the particle. What is speed of the particle here? For speed of the particle, V is equal to U plus AT, 20 plus A into T. T is 2 seconds. So this is 20 minus 20 is equal to 0. So here speed becomes 0 after 2 seconds. So 0, 0, P. So B match with P. Then C. Displacement of particle. Displacement of particle from what? Displacement of particle, okay, after 2 seconds. From this place to this place, how much is the displacement? The moment it leaves, after 2 seconds, the particle drops from the balloon. After further 2 seconds, how much is the displacement of the particle? So in next 2 seconds, the displacement is 20 minus 0, or you can say 40 minus 20, that is 20, and 20 is S. So C matches with S, and then remains D. RPS, RPS. So it has to be Q, but we should solve it. Acceleration of the particle. Acceleration of the particle after 2 seconds. Oh, it's a wonderful question, and you should always remember that whenever there is no additional force on any particle and it is free in the air or in the space, the only acceleration acting on it is due to earth. And how much is that acceleration? That acceleration is 10 downward. Okay, so what is the value of that acceleration? Don't mind the direction, minus हो या plus हो, acceleration कितना है? That is equal to g, and that is equal to 10. So our answer for acceleration of the particle is 10 units, because only g is acting on it. So D matches with Q. Okay, so this gives us all the answers. Thank you. Now we go for the next question. Here is the next question. It's a very easy one. Displacement time graph is given. The instantaneous velocity of the particle is negative at which time? when the velocity in displacement time graph is given by slope of the graph. And here when we say the line is going up, the slope is positive. When the line going down, slope is negative. Here line is going up, line is going up, line is going up. Here line is going down. Only at one location line is going down. What does it mean? Here the displacement is more, here the displacement is less. This is displacement. Because height shows the displacement, here displacement is more, here displacement is less. So more, less. That means the particle is coming towards me and the displacement is decreasing. If displacement is decreasing, then velocity is negative. So at point E, velocity is negative and our answer will be at E. E. This is the right option. The instantaneous velocity of particle is negative at the point E. At the point E. So this is our right answer.